Jai Hind everyone. Hope so you people are doing well. And here we are with another video which is about the carbohydrate metabolism. This is the first part of the video. Now let's see what are the topics which we'll cover here. So carbohydrate metabolism consists of the three major part. What it is, the gluconeogenesis, and then glycogen synthesis and glycogenolysis. The one more part is there in which we'll see the regulation of this carbohydrate metabolisms. So let's begin with the gluconeogenesis. This is about the synthesis of glucose from non-carbohydrate precursor is called as a what? Is called as a gluconeogenesis. Got it? So precursor, what are the precursor are available for the carbohydrate or glucose synthesis? So first precursor you can see here the glycolytic precursors like a lactate, glycerol, pyruvate, or the Krebs cycle intermediate, or amino acid except the leucine and lysines. All these are the precursor for the glucose. But we are going to discuss here about the glycolytic precursor. So, can fat form a glucose by gluconeogenesis? Is this a question? Usually, yes, only in the not in animal. So we don't have the enzymes which will convert the fats into the glucose. We cannot convert the fats into the glucose. We don't have a because animal doesn't have the enzyme for the conversion of the acetyl coenzyme to pyruvate or oxaloacetic acid, but plant do have. So glycolytic precursors will be the following as a lactate, pyruvate, and all these things we studied. What happening in the respiration if we'll go for the general way? So glucose will be break down into the pyruvate, and this pyruvate will further transferred into the converted into the acetyl coenzyme A, and then it will become the part of the Krebs cycle, and it will end up with the ATP synthesis. But we want to convert this pyruvate into the glucose. As you remember, there will be total 10 steps in the glycolysis, and there are three irreversible steps. There are three irreversible steps in the glycolysis. So we can easily convert the pyruvate into the glucose, but we have to bypass the three irreversible steps. So we are going to read this three irreversible step how we can bypass. So the first irreversible step is what? The first irreversible step is the glucose to glucose 6 phosphate. So glucose to glucose 6 phosphate is irreversible step. Second step is what? The second step is the fructose to fructose 6 phosphate. And then third step is what? The pep to pyruvate. What is pep? Phosphoenol pyruvate. So first we'll see the bypass of the third step. The how pyruvate will convert into the pep. So pyruvate cannot form a pep. That is true. And the pyruvate have to bypass with the oxaloacetic acid. So pyruvate in the mitochondria, the pyruvate, which is a 3-carbon compound, it will form a 4-carbon compound in the presence of the pyruvate carboxylase enzyme, and it will require one ATP as well as one CO2. Finally, it will be converted into the oxaloacetic acid. Now we have to pass this oxaloacetic acid to the out of the mitochondria. So how we can do it? It is not possible because oxaloacetic acid cannot cross the mitochondrial membrane. Remember it that 95% of the metabolism will occur in the liver. Now, two ways to cross the oxaloacetic from the mitochondria into the cytoplasm. The first way is the simple. The PEP, the oxaloacetic acid will convert it into the PEP by the help of pepcase enzyme, and there will be one release of the CO2 by utilization of 1 GTP. So this is present in the human, but pep carboxykinase, but the pep carboxykinase is absent in the rat and mouse. So how they will transport the uh, oxaloacetic acid into the cytoplasm? So in case of the rat and mouse, so in the case of rat and mouse, the oxaloacetic acid will take one NADH and NAD plus. In the presence of malate dehydrogenase, it will convert into malate, and now this malate having a transporter in the mitochondrial membrane, it will transport into the cytoplasm. Again, it will reduce the NAD plus into the NADH, and it will give you the oxaloacetic acid. Now, the mitochondria, like the cytoplasm of the rat and mouse, have the pep carboxykinase, which will convert the oxaloacetic acid into the pep. So we got a pep phosphoenol pyruvate. Now we phosphoenol pyruvate will form the 3-phosphoglyceric acid, then 1,3-bisphosphoglyceric acid, then 3-phosphoglyceraldehyde. Like that, it will going to be form all these things. But it will stop again at the second irreversible step. What it is? It cannot convert the fructose 1,6-bisphosphate into the fructose 6-phosphate because it is irreversible. So we required again we have to bypass this step by following ways. So the ATP required and the fructose 1,6-bisphosphatase convert the fructose 1,6-bisphosphate into the fructose 6-phosphate. So citrate, if there will be more citrate in the medium, if the more citrate will be there in the cell, then it is this conversion will be takes place. But if AMP and fructose 2,6-phosphate are there, then it will inhibit the fructose 1,6-bisphosphatase. Remember it, these are the inhibitors. These are the inhibitors. Okay, and these are the activator. So now finally we will get the fructose 6 phosphate. What you will do with the fructose 6 phosphate? It will form easily its isomer, which is called glucose 6 phosphate. Now this glucose 6 phosphate is unable to convert into the glucose. Then we need a glucose 6 phosphatase. This glucose 6 phosphatase will convert glucose 6 phosphate into the into the glucose, and it absent in the muscles and brain. This enzyme is absent in muscle and brain, so it cannot occur in the muscles and brain. So mostly it will occur in this all gluconeogenesis will occur in the liver. So what are the energetics? These are the energetics. 2 pyruvate and 2 NADH require 2 NADH, 4 ATP, 2 GTP and 6 water to form a 1 glucose and 2 NAD plus and GTP and 4 ATP. So how we can form a glucose from a amino acid? We already studied in the amino acid metabolism that how many like mostly alanine glutamines are the amino acid which will take participate in the formation of the ketoglutarate, and then it will go to the Krebs cycle or it can come back. So we will see the small thing, the glucose and alanine cycle. So in muscles, the pyruvate will be transamination in the presence of glutamine, and it will give you the alanine. This alanine, this alanine will transported from the blood and it reaches the liver, where this alanine will convert again the pyruvate, and again this pyruvate will go for the gluconeogenesis. And the conversion of alanine into the pyruvate, it will give you the aspartate, which will go for the urea cycle. If you didn't watch amino acid metabolism videos, there will be here somewhere, there will be one link over here. You can go through these links. Thanks for watching. We'll meet in the next video. Jai Hind.